Okay, we need to be able to work out interior angles of regular polygons here. There are actually two ways of doing it, and I'm just going to outline the first one, which I'm not going to use. The interior angle sum of any polygon is the number, sorry, that's meant to be a bracket, the number of sides minus 2 times 180. I'm not actually going to go into where that comes from here, but that is well worth knowing. And so we could use that here if we wanted to. However, there's actually, I think there's a nicer way of doing it, and that is to use the exterior angle sum. And that's always 360 degrees. So if I've got my hexagon over here, okay, and I want to work out this exterior angle, then I know the exterior angle sum is 360, so I can do 360 divided by the number of exterior angles, and there are going to be 6 of them as I go around, and I'm going to get 60. And therefore, I know that the interior angle is going to be 120, because interior angle plus exterior angle is always 180, and that's even if it's not a regular polygon. In that case, the interior angles and exterior angles will be different, but each pair will still add to 180. So yeah, let's keep going this route. Let's do it for the pentagon as well. So I want to find this one here. It's going to be 360 because that's the exterior angle sum. But this time they're all the same. I'm going to be dividing by 5, and that's going to be 72. So I can do 180 minus 72, and that's 108. Now I've labelled them here, but they're actually the same over here as well. So we've got 120, we've got 108. If I want to work out, oh no, I'm meant to be coming over here. My bad. 120, 108. Right, let's just do a bit of working. 120 plus 108 is going to equal no, not 100. 228. So therefore A is going to be 360. That's the angle around the whole around a point. 360 minus 228, and it is in fact 132 degrees. So it's a show that question. I think I've shown enough, working here for my 3 marks. I know I've abbreviated exterior angle sum, and interior angle sum, and interior angle, etc. You might want to write down a bit more. You might want to explain your jargon, but I can't fit it in here, and I think that's right. Imran thinks that another tile in the shape of regular polygon will fit exactly into angle A. There's always an interesting problem. How can you sort of, tessellate kind of different polygons together? Right, will it work? Well, I'm going to keep using exterior angles. We could, play with the interior angle sum and stuff, but this exterior angle is just much nicer to deal with. So the exterior angle of the polygon would equal 180 minus 132, which is 48 degrees. So we've got that 360 is going to have to equal, sorry, I've got this wrong around. 360 divided by the number of sides will equal 48 if we can fit a regular polygon. I feel like I've not really explained this, where this formula has just come from. We know for a regular polygon that the exterior angle sum is 360. Well, that's true for any polygon, but we know for a regular polygon we can then divide by the number of sides to get each individual exterior angle. So the opposite is true, really. If I can have a regular polygon in the space, then it must be that 360 divided by the number of sides will equal this 48, this exterior angle that I obtained. So I can rearrange this. I can multiply by n, and then I can divide by 48. N will equal 360 divided by 48, and now we just need to figure out what that answer is and whether it's a nice whole number. Can we get a nice whole number of sides? So I'm just going to go the nice route of I'll just divide top bottom by 2. 120 divided by 24. Let's have it again. 90 divided by 12. And this is a problem because this is not, I should probably keep going, but this is going to be 45 divided by 6. I'm just dividing by 2 every time. Now I'm going to divide top and bottom by 3. I'm going to get 15 over 2. I'm going to get 7.5. So show your reasoning. I think I've shown enough. It is, I can't quite fit it in that line, so no, it is not possible. Have I shown enough for 3 marks? I reckon I have, but maybe I should just write a little bit more. No, I think that's enough, to be honest. Let's just leave it at that.